All right, my wonderful children, today we are talking rate of change and slope. And I'm sure you can remember some of this stuff from earlier in our lives. I know we've talked about rate of change before, and slope, but we are getting into that a little bit more today. So, when we are seeing things like rate of change, so the rate of change this is the ratio that compares the amount of change in dependent variable to the amount of change in an independent variable, or the amount of change in our x and the amount of change in our y. It compares those two things. So if I were to say, all right, I have a table here, and on this table I have days and money. And this is days of the jogathon and how much money we made. So 1 day, 2 day, 3 day, 4 day, 5 day, 6 day. As a school, we made $100, $240 total dollars, $580 total dollars, $1,075 total dollars, $1,480 total dollars, and a grand total on day 6 of $1,910 total dollars. And I said, all right, I want to know, what is the rate of change each day of our jogathon? Well, to do that, I want to make a ratio of change of days over, change of money over change of days for each pairing I have here. So I have a pairing here between 1 and 2. I have one between 2 and 3, 3 and 4, 4 and 5, and 5 and 6. And I want to know, all right, what's my ratios here? All of my change of days on this table happen to be 1. It's 1, 1, 1, 1, 1. And so since this is a ratio and I'm dividing by that change of days, I'm always going to be dividing by 1. When I divide by 1, do I actually need to divide by 1? No, I do not. So I'm not going to worry about the dividing by 1. Just know that it's there. I'm going to care about what's my change between these values. Day 1 was $140. I take my bigger number, I subtract my smaller number. Then I have 580 minus 240 gives me a total of $340. Then I have 1,075 minus 580 gives me $495. Then I have 1480 minus 1075 gives me $405. And then finally I have 1910 minus 1480 gives me $430. So I can see how this is changing each day, and I can tell my biggest change here happened to be in between days 3 and 4, where we as a school made an extra $495. That's the biggest amount we made for this move-a-thon. If I wanted, I could graph this, and we could see how this all pans out. Day 1, 2, 3, 4, 5, 6, and then we'll go by big gaps of 0, 500, 1,000, 1,500, 2,000. Okay, day 1, we were real low at $100. Day 2, we were about halfway through. Day 3, we were right about here. Day 4, we were over $1,000. Day 5, we were under 15. And day 6, we were almost up to 2. Then I draw my lines connecting the dots here. There's one, here's one, there's one, there's one, there's one. And I can see how my graph is changing. Each change in between 2 points here happens to then be, this is all the rate of change. Everything, all of these lines, these are all the rate of change. I'm going to spend a ton of time on rate of change. I really want to get into talking about slope. Because as we all know, the slope is a major part of graphs. So when we talk about slope, there's a couple things we need to know. We need to know about the rise. We need to know about the run. And we need to know about the slope. All right, now we think, all right, so we have a graph here, yes? And on this graph, I've got a line. We'll make it a nice, good straight line here. Okay, look at this. What a wonderful, beautiful straight line I've made. All right. So we think about the rise of a slope. This is the change in y values on a line. When I talk about the change of values, I'm talking about 2 points. I'm going to put a point right here and right here. And we'll call this point -2, 6, and we'll call this point 3, 4. Okay, so the rise is the change or the difference in the y values. So I guess this is -2, -6. So to find the difference, I'm going to subtract. I'm going to take y1 minus y2. I don't care what y1 is or what y2 is. We'll call this point 0.1 and this point 0.2. So we'll say this is actually 4 minus -6, which is 10. So my rise here is 10. I could actually count these and go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and see that I go up 10 to get from this point all the way up to where my other point is. The run is the change in x values on a line. So again, I'm going to say, all right, well, I want to do x1 minus x2. My x of 0.1 is 3. My x of 0.2 is -2. 3 minus 2 is 5. That's the same thing as saying, all right, from this point here, I'm going to go over 1, 2, 3, 4, 5 units to get from -2 to 3. So my run is side to side. My rise is up and down. Rise is up and down. And then my slope is the ratio of the rise over run. So I take my rise, I divide it by my run, and that gives me my slope. So my rise was 10, my run was 5. 10 divided by 5 is 2. I have a slope of this line of 2. Okay, so slope will always equal, and this is like one of the things we should write down and just know this forever. Slope equals rise over run. Okay, slope equals rise over run. And when I have something, so I'm going to change my background a little bit here. Give me like a nice graph. Wonderful. Okay, let's see. Did that give me like a middle point on my graph? Am I just like off in the middle of nowhere here? No, I'm not. All right, so if I have my graph here, this actually gives me some graph lines, which is great. If I said, all right, I've got a point here and a point here, and this is my slope. Here's 2 points. This is a 1, 2, 3, -3, -1. This is 1, 1. Okay, so I can do that math. I can do the thing, or I can divide, or I can look and say, all right, I'm going up 1, 2 over 1, 2, 3, 4. I've gone up 2, rise 2 over 4. 2/4 equals 1/2. My slope is 1/2. I can just count how many units I go up, how many units I go over, divide that, and that will give me my slope. It doesn't actually matter if I'm counting this way, or if maybe I'm counting the side way over here and then up that way. It doesn't actually matter. It's going to give me the same kind of information. Now, you might also have points. I'll get rid of all these things. I don't know why I just deleted them all this way. You might have points on your graph that look like here's a point and here's a point. This is -1, or this is, sorry, 1, -3, and this is 0, 4. And so my line of this line is going to look something like that. So again, I can check and I can go up. Go up 1, 2, 3, 4, 5, 6, 7. Rise 7. Go backwards 1. This is a slope of 7. Okay, so here's the deal. When I'm rising on a graph, and the reason I did this is when I'm rising on a graph, anytime I'm going from one low point to a higher point, when I'm actually rising, that's a +7. If I happened to be going down from one point to another, that would be a negative value. And that changes because negatives and positive change when we divide things. So we need to know what's positive, what's negative. Going up for my rise is positive. Going down for my rise, I can do, it just happens to be negative. And then going forward for my run will give me a positive value, but going backwards for my run will give me a negative value. So this, I ended up actually going backwards one place. It's actually a -1 run, which makes this a -1, which means positive divided by negative. This is actually a slope of -7. It changes a little bit here. It changes when you have slopes and the direction that you are rising and running. Up is positive, down is negative. Right is positive, left is negative. Okay, so I would write this down here so that when you're doing slopes, you can remember the direction changes the positive or negative values. All right, a couple other things I want to talk about give you some examples here of different graphs. Back up a little bit. Okay, and this is just a general looking graphs that start down and go up like this. These are positive graphs. Graphs that are going at a downward spiral, not spiral, but downward line. These are negative graphs. If my graph happens to be going side to side perfectly, this is a zero slope graph. There's no slope to this. It's going perfectly side to side. It's a zero slope. And if it happens to be going perfectly up and down, this is called undefined slope. So up and down is undefined. You can't do it because you end up having a run of zero because it's not going side to side anywhere, and anything divided by zero you can't do. So this is an undefined slope because you can't divide by zero. You can't have a ratio where zero is your bottom number. This is undefined. Okay, so positive, negative, zero slope, and undefined slope. All right. And that's going to be what we need to know today. Slope, rise and run. Okay, we need to know our rise, we need to know our run. We need to know the direction and what kind of slopes we're looking at here. Remembering rate of change will be good, but most importantly, I want you to remember the slope and all things slope. If anything's going to stick in your brains today, let it be that. All right, children, have a wonderful rest of your night, and I will see you all tomorrow.